There's two types of tool measurement gauges in our industry. The first is contact gauges. The second are non-contact gauges. And we're going to look at the differences between these two classes of gauges by looking at three factors. First, contact gauges use measurement probes, and these here are seen, for example, on this tri-mic, that these probes come directly in contact with the tool. This probe here can be configured in various ways to measure diameter of punches, and with this type of a probe, again, the probe comes in contact with the tool. Non-contact gauges use non-contact technology. So here, the ToolScan 2.0 uses green LED micrometers to measure the tooling. Contact gauges typically measure single tool geometry and type, meaning that this tri-mic will measure dies and only the inner diameter of those dies, where non-contact gauges are more versatile. They measure various tool geometries and tool types. The ToolScan 2.0, for example, measures body maker punches, dies, and more. Contact gauges have fair accuracy and repeatability, where non-contact gauges have excellent accuracy and repeatability. And the best way to show how non-contact gauges look is by showing you a couple of videos. On the top, we show the ToolScan 2.0 measuring a punch, and on the bottom, an ironing die. It's important to show that it being a non-contact gauge, the green LED micrometers, of course, never contact the tool itself. Another thing I want to point out is at the bottom, we're showing the ToolScan 2.0 being used with the tool control system. So right there, the barcode scan that is happening will connect with the tool control system, which is our tooling inventory and tooling tracking software that we'll be releasing in 2020. We'll have more on tool control a bit later. It's important to say that unreliable inventory is corrected simply by gauge accuracy and repeatability. So to see if your toolroom gauge is performing as it should be, we've given you a quick test. So go to your inventory and randomly select 10 tools. Then record the marked diameters on the tools on a sheet of paper, after which I want you to erase those markings from the tools. Then go ahead and remeasure all 10 of those tools and compare the original value with the new value. If there are any discrepancies between old and new, you likely have a gauge performance issue. And these discrepancies in measurements would likely cause performance issues when inserted into the body maker. So remember that the lack of repeatability is often the fault of the gauge and not the operator. A toolroom operator can only do as good as the gauge they are provided with.